Good afternoon, everybody. This is Greg Wadley with CTC and Associates. I'm the administrator for Clear Roads. We are here today with a research team from the Midwest Regional Climate Center at the University of Illinois for the final webinar on the project Accumulated Winter Season Severity Index, or AWSSI, Enhancements in Support of Winter Road Maintenance. As a reminder, I'd like to tell everybody that if you have any questions, please go ahead and put those in the chat box and we'll answer those at the end of the presentation. So I will turn it over to the research team now. So go ahead whenever you're ready.
All right, thanks, Greg. This is Steve Hilberg. Mike Dimlin's here with me and he'll be jumping in shortly. And we're going to review what the tasks were for this project and what was accomplished as we went through this. All right, let's see. These are the project tasks. The first one was to add at least one additional location, basically a first order or co-op station to each Clear Road state for which we could calculate AWSSI. Task 2 was to add the ability to overlay past years on the current year AWSSI time series plot, so you could look at historical years that were similar or different, however you wanted to do that. Task 3 was to develop a projection for the remainder of the winter season and display that on the chart. And finally, the task 4 was to determine the feasibility of quote road AWSSI. The first two tasks were completed by the end of June this year, and then we completed tasks 3 and 4 at the end of the calendar year. Task 1, add at least one additional AWSSI location to each Clear Road state. So to do this, we asked states to submit 3 counties from their state in priority order, and we received selections from all but one state. What we tried to do is to meet these priorities. That wasn't always possible due to where the county might be and whether or not there was any stations in it, and if there were, whether they had the data that was needed to calculate the AWSSI. We were able to add stations. As you can see, we actually added more than one station per state. We added a total of 51 to the map as part of this project. The reason we were able to add some extras was due to readily available data, ease of actually adding them. In some cases, especially out west, less populated areas, it was more difficult to find stations. We actually had to go through, look at station history. Sometimes the history would indicate that, for example, snowfall data was available through, 2017, but when you went back and actually looked at what was inventoried, it was much less. In fact, there were huge gaps, and perhaps they stopped measuring snow 4 years ago. The metadata for these stations isn't always up to date in the finest sense. At NCEI, so we had to do a lot of investigation to see what stations we picked were actually suitable for being included. So as I said, a total of 51 stations added. We'll see those on the map in a little bit, but I'm not going to list them all. That we did send it as a separate document, so they'll eventually be posted to the website. So a station had to be currently reporting temperature, snowfall, and snow depth. Those are the parameters we use to calculate the AWSSI. In order to obtain the range of winters, the quintiles, the categories, we prefer that there were 30 more years of winter season data. And that's where you run into problems with missing data. All but, I think, 5 locations, I think it was 6, now that I look at my list, all but 6 had 1 or more seasons eliminated from the analysis due to missing data, and in most cases that was upwards of 5, 10, 15. In one case we had almost 30 years missing, but the 66-year period of record, that was okay. The only problem with that is if those years are clustered, which they tended to be sometimes, it could actually affect the distribution a little bit, because if they're missing particularly cold or particularly mild winters, that would affect it somewhat. Stations selected were a mix of first order stations, which are typically the airports or weather service offices, and then the U.S. Cooperative Network stations. Well, we'll see a little later on the map, some of the U.S. Co-op network stations, they're all volunteer observers, and depending on where they are, sometimes they update every day. Their data is submitted electronically and is included in the daily data that gets distributed, but a number of them only submit their observations at the end of the month, and once that process is, then they are added, and we can grab that data and add it to the map. So, and since this is not necessarily really a real-time monitoring, it's a monitoring tool, but not a real-time operational tool in the one sense, this is good, especially for retrospective data. So I'll turn it over to Mike, who did the majority of the work on tasks 2 and 3.
Okay, hi. Hope you can hear me okay. So I'm going to start talking about task 2. And first thing I'm going to say is when we started this out, we had the time series plots, so we could go, and actually let me just pull this up really quick. This is when we have the AWSSI tool, and you can see the extra stations that are on here now as well. If you go to one of these stations and pull it up, you can go to the specific station and pull up a chart, and it will show you the time series of the current year, and it will overlay the historical quintiles, or 20th, 40th, 60th, 80th percentiles, so that you can get an idea of where this season ranks among the historical seasons. And so this is basically what we had as a figure when we started the project. What we did in task 2 was add to that. So just wanted to kind of set the stage there before I start talking about this. So for task 2, we had the historical data, like I said, in quintiles, but we didn't actually have the individual seasons available. So what we had to do was go back and make all that historical data for each of the past seasons available back to 1950-51. Then we put all that together in a place where we could work with it. That would allow us to actually put it up on the plots as well. So when we started this process, we had one menu that basically, once you were in that time series plot, you would be able to go in there and choose a different station. It would jump and show you the information for the current season and the quintiles for the other station. What we did is we went in and added a second menu there that gave the historical seasons were all listed, and you could go through and pick out a specific season that you wanted to look at. We've expanded that since then when we got to task 3. So when we were completed task 2, we basically went from just having a station menu to having a station menu and a historical seasons menu. One of the things we had to deal with was what to do in the cases if you chose a historical season that was thrown out because it had too much missing data. In those cases, we just have a pop-up that will come up and tell you that the historical season that you chose doesn't have enough data. We looked into things like just having the menu only list the seasons that were available, and we ran into some issues when we got into task 3 and started laying out what we were going to do in task 3, when people would be switching back and forth and trying to keep all the menus up to date and not have strange things happening. So we just went with a warning that just pops up and says the historical season you chose doesn't have enough data. So for some of the stations that have a lot of years that are missing, that can be a little bit problematic, but hopefully that'll work well enough, and it allows us to do some of the other stuff we did in task 3. So let me go ahead and show you what they look like. What we've done is add a red line to the plot. So if you want to see historical seasons, like I said, it used to be that there was just the city menu and the season menu, but this will show the previous season's AWSSI score as it went through, developed through the year. You can go back and choose a different season and see how the different seasons develop through their year. If we switch this, I'll pull up an example. Some missing data. If we went to Chicago and went back to 95, you get this pop-up that just says the 95-96 season has insufficient data. And then when you get the plot, it just doesn't show anything on here. So that's what we did. If you go back and pick a different year that has data, then everything's fine. So that kind of wraps up what we did on task 2. Now I'm going to go on and talk a little bit more about task 3. So here's where we were going to use the historical information to project for the remainder of the winter season. So like I said, while we were working on task 2, we were working on task 3 at the same time. Even though they had different deadlines, we were already involved in figuring out what we were going to do, how the interface was going to work, and I'd already kind of talked about this a little bit, that we took into account how we were going to have to do that. So we just used that pop-up for seasons that don't have enough data, and we kind of laid out what we wanted to do. So while we were doing that, we realized what we were proposing to do in task 3 was to show projections of the rest of the season based on the last 5, last 10 seasons, or the closest 5 or closest 10 seasons, or the analog years, the ones that are closest to today's score in past years. So while we were figuring all that out, we kind of realized that the best way to do this, to keep the interface clean, was to just provide a selected season, last 5 seasons, last 10 seasons, closest 5 and closest 10 seasons, for both the historical information and for the projections. And that actually allowed us to simplify how we did the menus. So we came up with a new set of menus, and so the first one is still the station. The second one is basically just to choose either just show the current season, show historical for the full season, or use just show projections. So the second menu just has those 3 choices. Then based on what you choose there, the other menus are made available, and the choices, the next menu, you get to choose whether you just want to see just a selected season, last 5, last 10, closest 5 or closest 10. And if you choose a selected season, then the menu that actually gives you those specific seasons, so you can choose which is the specific season you want to see. So hopefully when I show you that, you kind of understand where we're going with what we did there, or if you've already played with the tool. So like I said, that expanded what we had for the historical seasons. When we did task 3, we just went ahead and expanded that as well. And we're projecting data for the remainder of the season using historical data. And I'll actually show an example where you can see that basically we're just taking that plot for the time series for the historical season, we're adjusting it to today's score and then showing that for the rest of the season. And that's how those projections are done. So, and I actually already went through all this. So I'm just going to go ahead and jump back over to the plots and show them. And again, here we're doing historical seasons in red. If we do projections, we're going to do it as a blue line, just so that hopefully visually you'll be able to realize that you're looking at something different. So leaving this just on the historical seasons here, I'm going to go ahead and say we want to do a projection of the rest of the season. Rather than show the red line for the full season, now we're just seeing a blue line that's tacked on at the end of the current season. And you can see that basically it's just taking that red line and moving it up, and that maybe isn't the best season to show something interesting where you can really see it. But here's a little more exciting year to look at. And if we switch this to projections, what you'll see is that red line will just be shifted down so it matches the end of the current season, and then it'll just continue out for the rest of the season that way. So that's how we're doing the projections. The other options in here are to have the most recent 5 seasons. So that's and you can see here the years that are actually listed on there. So the most recent 5 seasons. You can do the last 10 seasons as well. And then the 5 seasons that are closest to the current score. So if I can switch this back to historical, you can see that all these are pretty close to the current score, because that's how we chose them. So there's not much of an adjustment on those for the rest of the season, but that's an option. Depends on the time of year how much those things are adjusted as well. But so that'll show you what you can do for all those. One other thing I just wanted to show is if you do this and want to see these specific years and want to know which one's which, there's a couple different ways. You can look at this mouse over, and it'll show you all the different lines that are plotted. It'll show you what the values of all those lines are. These bottom values down here show what the quintiles are, but the top, in this case, 10 lines, is showing you what all those different values were for different years. And the other thing you can do is you can come over here and click on things, and you can turn off lines. So if you just want to see a specific year, figure out which one it is, you can say, okay, now I know that that's the 73-74 season. Turn that off, and now I want to look at this one, which is 2003, 2004. I can see what specific years are doing. Okay, so with that, I'm going to turn it back over to Steve to talk about task 4.
Okay, this one required a little more analysis than most of this so far. So there were several steps to this. One is to get some state operational road maintenance data. And a whole point of this was to see, is there a way to optimize the AWSSI somewhat to do a better correlation with winter road maintenance costs? An initial looks at this, it actually had a very good correlation, but there's one or two samples, and we wanted to see if we could tweak anything to improve that. So I requested road maintenance data, and Greg was able to round up data from the following states, actually from a number of states, but we used these 6 states for the analysis. And rather than costs, which vary not only year to year, but season to season, depending on cost of materials or labor, whatever, we basically used the number of labor hours, the number of equipment hours, and the quantity of road treatment materials used. And that was a pretty common denominator throughout the whole thing. Everybody pretty much keeps track of that. And we could actually use that to compare the AWSSI to. So all these data were normalized by computing an average for the years that were available, and that varied again from actually 5 to about 13 years or 14 years. And then we'd calculate the percent change from average for both AWSSI and all the different categories of road maintenance data. So we ran these correlations for the state as a whole using averages for there was state data, and then there was also district data in most of these states, your transportation districts. And for state data, the labor and all that material was there. For the AWSSI, we averaged the AWSSI among whatever available stations were in that state each year. So if there were 10 years that we had, that we averaged the AWSSI for 10 years for 6 stations or 3 stations or whatever we had. And then if there were any, shouldn't be 4, but 4, but if there was a district in a state with an AWSSI location, where we did try and get them in districts if we could, we ran the correlations for that district as well. So we tried a couple different things. We ran it against the AWSSI, of course, and then since this is road maintenance and a lot to do with snow, we tried running it against the snow score component, which is snowfall plus a snow depth score. That didn't improve anything at all. In fact, in most cases, it was about the same or lower than with the AWSSI. So that one just didn't seem like it was going to work very well. So we had talked with Brian and others about events, a number of storms, however you wanted to do it. And so we came up with an event-based index by summing the AWSSI snowfall score and the temperature score only on days snow was reported. So if you only had snow on 4 days during the winter, then you'd only have 4 days of scoring. And we called this the ROSSI, short for road AWSSI. And this did not include the snow for total depth of snow on the ground. So since that seemed to be didn't seem to improve the correlation very much. And in fact, if you added depth of total snow on the ground, you're basically almost talking about the AWSSI on an event basis. So ran these correlations, and this will give you an idea of what we were looking at. It had a slightly, this new AWSSI, this modified AWSSI, had a slightly better correlation to operations data, but it varied by state, even within districts within each state, and that especially is true out west. In many cases, those differences weren't significant, but you can see here for Idaho that labor hours, it improved the correlation by from 0.44 to 0.47 or 0.48 if you round, which is a little bit of an improvement, but you can see from the chart there's quite a bit of scatter. And that's for the state as a whole, and for 6 winters there. If you started looking at districts, the correlations actually got a little worse because we'll talk about that a little bit later. So this is for all 6 stations for the state correlation. So you can see in Arizona, neither the AWSSI actually does better than the road AWSSI, but overall their correlations aren't quite as good as some other states. Idaho is about the same as Arizona. Maine, you see an extremely high correlation, 0.81 for the AWSSI and 0.87 for the RAWSSI. Maryland, Maryland was my favorite state for this because, boy, I don't know what, we just got good stations and good data, and everything correlated very well. Labor correlated 0.98, 0.97. Equipment, materials used was excellent. And I can't explain that exactly other than the stations are in the right place for describing their winter climate. North Dakota was not too bad with the AWSSI, was 0.84, but really suffered with the RAWSSI, dropping down to about 0.69. And even at 0.69, those are not bad correlations. Those are actually pretty good. Equipment there was not very good. And we'll talk about why in a little bit, and the same with materials. In Pennsylvania, correlations were pretty high as well. The biggest differences you'll see with correlations are in the equipment and materials categories. Labor hours seems to be a pretty good indicator of activity during the winter. So why did some of these do better than others? Well, one, it's important that the stations used for any correlation to winter maintenance reflect the climate of the district. And early on, we ran into this with Maine. I talked to Brian, and we had picked a station that had a pretty good period of record, Jackman, Maine. For the district that was in, it was not a very good representation of the winter weather. Their winter weather is a little more severe, and I forget the name of the station we eventually chose instead of that, and the correlation was better. Out west, we see real problems. Idaho is a mystery. Some of it depends on if there can even be a weather station where they're having to treat roads. We had problems. It just didn't correlate well. And my assumption is that where the weather station is underrepresenting the winter, because the winter's at higher elevations that they do get into, and we don't have any weather stations there with good records. And out west, there's a limited number of stations available, period. In less populated areas, you have less available people to make those observations. And when they're there, then you got to deal with the missing data. So that seems to be, like I said, especially true out west. And the interesting case in point was Navajo County, Arizona, which prior to this winter, people would say, well, they don't get much winter. And they've had a lot of winter in Arizona this year. But here's the example. Arizona, that county is long and narrow, pretty much extends from the southern border to the northern border of the state, about 236 miles north to south, but only 50 miles east to west. Now, the one good station there with data is Show Low, Arizona, but it's in the far southern end of Navajo County and 188 miles from the northern border. And well, the thing that stuck out to me was that in the winters of 08, 09, and 09, 010, there was no measurable snow in Show Low. The RAWSSI was 0. But the equipment used by the DOT in that county was 50 to 52% higher than average, than the 10-year average. And in 09 and 2010, the equipment hours were actually the highest of the 10-year period that we had to look at. So, but during that same winter, the AWSSI was 27% below average. So something was a big disconnect. So I went and looked further at that to see what was going on. And this is the type of thing we can run into out west. The graph, the chart on the map on the left is the winter of 08, 09. And then the one on the left is 2009, 2010. The pattern's fairly similar for those winters, but you can see that most of the snow came to the west. This is Navajo County right here, and Show Low is about right here, but it did not have very much, well, it didn't have any snow in these two winters, although this map indicates there might have been some snow. These are smooth, so you can't necessarily rely on that. You have to look at the data. But probably the road maintenance was largely south and west of Show Low, where they really had activity and really had a decent amount of snow. Even up in the northern part of the county, they had some. So ideally, you'd want a station here, a station here, and a station here for just this one district to adequately represent the district. But as you can see, those dots represent stations, but not all the stations have good period of record or long enough period of record to actually use the AWSSI with. So we can run into this a lot out west. And that is going to be an issue trying to use the AWSSI. But again, local people, I mean, folks in Arizona know their territory, know what they're dealing with. So hopefully they can make adjustments, knowing all their local stuff plus what's going on. So, but what we found out was that both showed a significant correlation to road maintenance, and labor hours was the real one that really stood out as a parameter that correlated well. The problems are we have variations from state to state in topography, obviously climate, and even road maintenance parameters. Different, materials used is not necessarily standardized. We get tons of salt, tons of sand, gallons of de-icing material, but it gets a little tough trying to put that all in the mix. What we can provide is, and so trying to set up one modified index to satisfy everybody's needs just isn't practical, and probably even possible because of the variations. So what we can provide are the AWSSI, both the temperature score and the snow score components, which are added together to compute the AWSSI, the road AWSSI, which is an event type index, and then we threw in the total number of snow days, basically days with snowfall greater than 1/10 of an inch, in addition to the maps and charts. And basically your event is a number of days that the AWSSI is calculated, because it's only calculated when you have measurable snow. And this will allow you to play with some of the parameters to determine which correlate best with your operations. And this winter is going to be an interesting one as well, out like where we're at. We're in an average winter, but our snowfall is well below average now. It's just been temperature that's been driving the AWSSI. And being able to see these scores individually, you'll be able to see what's really driving it in any particular year. We look out in Maine, and Brian's dealing with caribou, which is now racing toward possibly a record AWSSI if they keep going this way. And but you have to look at the individual components to see what's driving it. Obviously, up there it's both snow and cold, but this winter is a good example of some of the disparities on how we calculate the winter severity. So what we decided to do is just provide all this data in a form you can download, and then you can individual states can determine what works best for them. Let's see. Okay, that's the presentation right there, and I think we're going to show the. Yeah. Okay, I have that up here. Yep. So talk to me about that.
Oh, okay, so what we did is put together a second web page. Hopefully we're going to figure out a way to get this onto the same AWSSI pages that are on for everybody else, but at this point we wanted to make sure this was finalized and what we were going to do, and if you guys had any feedback to change things, we wanted to make sure that was all taken into account before we put this on there and had other people confused as to what's going on and why these changed. But all the different stations are here. You can click on whichever station you're interested. It'll pull up a CSV file where you can get all the information. It has all the seasons historically going back. It has the start date, end date for that season, the length of days in the season, number of missing values in that season, and the scores for the maximum temperature and minimum temperature, and then those sum together to give the overall temperature subscore, snowfall, snow depth, and overall snow score. And again, this is snowfall and snow depth added together to get the snow score, what the AWSSI was at the end of the season, and then how many events there were during that season, and what the road AWSSI score was, where we summed up the snowfall, the temperature scores on the days where we had snowfall. And so all those values are available for you for the end of the season for all the different stations, and then hopefully you'll be able to use that and be able to get the information that you're interested in for doing your correlations, depending on which data you're trying to correlate it to and what you have available for your operations costs. I think that kind of wraps things up. So if you guys have questions, we'd be happy to answer those.
All right, thank you. Appreciate that. So looking in the chat box, I don't actually see, excuse me, any questions here. So what I'm going to do is I'm going to take everybody off mute, and then if anybody has any questions at that point, they can go ahead and ask. So let's see here. All right, so everybody, well, most everybody is off mute now. So if you have a question, please let me know. And if you're not able to get through audio, go ahead and enter it in the chat box.
Okay, this is Brian. Can you hear me all right?
Sure can.
Yep, we can.
Okay, good. I might have missed this, but when you were showing the where you can download what's on the screen now with the road AWSSI and the summaries for each year, did you say how that's going to be linked in the future, or how we're going to get to that?
Well, right now there's just the separate link that I sent you to get to that page. What we're hoping to do is just have another menu on there that just says download the data, or just a box or some kind of place that you can click on. We ran into a couple of issues there. Being able to change the station that you're interested in while you're on the time series plot confused the part for trying to figure out which data to download. We want to make sure that you're getting the downloaded data for the correct station, just because it'd be really confusing for somebody to be looking at one and hit download and not realize that they're getting the data for the first station they looked at, not the one they're currently looking at, and things like that. So there's a little bit of stuff we need to do on the back end, but we wanted to make sure they were available, and we'll continue to figure out what we need to do to make that more useful so that you don't have to go to a separate page to do it. You should be able to just download the subscores.
Okay, excellent. Thank you very much. And I also appreciate that you showed that you can shut off the lines by clicking over on that menu when you've got like the 8 or 10 seasons being shown. I didn't realize that, so that was good to know.
Okay, any other questions? All right, Brian, do you have any final thoughts on this project?
Just a great job. Thanks to both of you. That presentation, really makes everything clear and wrapped it all up nicely. I think you did a great job with this project. I think the website is got a lot more neat features on it that are going to be helpful to a lot of agencies. So thanks a lot.
Great.
Hey guys, this is Joe in New York. I just wanted to second that. Looks like a nice tool. I see the one disclaimer about the precip type and not accounting for freezing rain. That's the only thing that was something, I guess, for the future.
Well, the issue with that is freezing rain is not something that's measured by the daily observers. And we have no way to easily access that data as part of a daily summary. And we're not using hourly data for this. So that's the rub on that. And we're fully aware that we don't have freezing rain or wind data in here. Wind would be helpful too, because you're gonna have sunny days, snow on the ground, and you got 40-mile-an-hour winds. You're still out plowing through the roads because of snow drifts. But that's one thing that we know is a shortcoming of this. We knew this. Barb Mays and I, who developed this index, knew that going in. But even so, it still does a very good job of measuring the severity of winter. One thing we wanted to mention, you'll see on some of these. Well, since we're talking to somebody from New York, yeah. We have, you'll see some of those circles here are gray. And this one for Mohonk Lake this is one of those co-op stations that basically submits their data at the end of the month. So their data is only complete through the end of January right now. In about another week to 10 days, the February data will be in, and you'll see this thing be complete through the end of February. But they do take the measurements. The input of the data is a little later than normal. We have another one up here in North Dakota, Upham, North Dakota, who was motivated to start reporting his daily data because of the AWSSI. He was a guy that reported at the end of every month. And when it wasn't there, and I inquired with the Weather Service why that data wasn't coming in, they talked to the guy, and apparently he's now reporting his data every day electronically, and he's up to date through today. So, but if you see the gray dots, they are reporting data, and but it's just because they're co-op stations, that data sometimes doesn't come in until the end of the month. And any station, we had another one in Missouri that we basically had to remove from the map because I think he just stopped altogether. The problem with the co-op observers is that, you know, they'll go on as long as they can, but sometimes if somebody passes away or moves or just quits because they're tired of it, it's often hard to get somebody to take over. And usually there's large gaps in the data then until somebody new starts up. And we see that all the time in the records. But there's still, you know, there's still good data out there. It's just a matter of when it gets in. And for a retrofit, by the end of the season, all those dots will be non-gray, hopefully.
Good. Does anybody else have a question? All right, well, what I was going to say was we will have the links up on the Clear Roads project page to the AWSSI plus that other link to the data until we get that sort of incorporated into the AWSSI site. And we'll also have a write-up on there that sort of captures what the research team did to get through the process here. It sort of covers in a way some of the things that they covered in the actual webinar. So with that, we'll thank everybody for joining today, and have a great rest of your day and week. Bye, everybody.